Okay, everybody, good morning to you. So let's take a look here and let's remember a few things, what we were doing. We were working on graphing some what? Trig functions here. So I'm looking at that. Okay, looks like the wireless is a lot better today. So we're looking at graphing some trig functions, functions that look like this, sines and cosines to begin with. Now, I want to remark, I'm going to put this here in the, in the chat there for all of you. And I want to remark about something here. I want to give you another definition. So let's go back. Another definition here. This portion in orange related to your period, right? We have here what we call an interval of one cycle. So I'm going to give you guys that definition as well. It's in our book. Definition of the interval of one cycle. Because what you are seeing here again, as we looked at yesterday, as I get out our Microsoft Excel, this is actually an interval of one cycle. So, okay, let's open that. Okay, now you might say, what do you mean? Well, this whole thing here, we're talking about this kind of interval that starts at 0 and then ends at what? At 2 pi over k in general. That's the period. So the definition of that interval of one cycle, and I'll just say I for interval, it's a closed interval. It means you start at 0, and yes, you end at the what? Period. Okay? But you guys know the period is actually, in general, what? 2 pi over k. Okay? So what we mean by that is you start at 0 and you end at 2 pi over k. So what this is really saying is that the values of x are going to be between 0 and 2 pi over k. So this is what they also ask for you in general, is the interval of one cycle here. Okay, so that's the definition of your interval of one cycle in general. So that's what they're talking about here, where you start, and where you end in terms of these values of x, because this is the x-axis. So, okay, so that's something they gave us. So you might say, well, how do I use that definition again? Well, if I go back to this first graph, or you don't even have to look at the graph, but I can use your definition of the interval of one cycle now, right? So for this sine curve, where do you guys start for this example? Right? Remember this one? They asked us to graph this 3 sine 2x. We did that yesterday. So the interval of one cycle, without even looking at the graph, we know starts at 0, ends at what? P for the period. And our period was what? Pi. So there you go, ladies and gentlemen. So here's my interval of one cycle. Start at 0, end at pi for this particular example we did yesterday. And this is what they're talking about here. This interval right in here. The values of x from 0 to pi. Okay, it's your definition. What about this one here, right? Interval of one cycle, we already know by definition, starts, where do you start on this? You start at what for this one? You start at 0. And where do you end? A pi. Okay, so I just want to give you guys again that definition, because if you looked at your homework, you said, hey, what is this interval of one cycle, right? If you looked at that book, well, it's from 0 to 8 pi. You start at 0, you end at 8 pi. Okay, here's a picture of that interval of one cycle here. Okay, these are values of x. So it's from 0 to 8 pi for that one cycle. And even with this minus 4 sine pi x we did yesterday, you say, what's my interval of one cycle? Well, you start again where? At 0, and where do you end? What's the period for this one? It's in our notes. You end at 2. So your interval of one cycle, this is what they're referring to right in here. Okay, from 0 to 2 for that example. All right, and so let's do another warm-up here with sine before we go to cosine. And another example, okay, because you might say, what if they give me something like this? Y just equals sine maybe of, oh, if I looked at that worksheet, where's that worksheet online? Yeah, you got 2 pi. Yeah, we'll do a minus. How about that? Let's do this. Where are we at? Okay. They said, what about a minus 3x? Okay. Now, they're going to want you to find all those things again. They're going to want you to find the amplitude. They're going to want you to find the what? Period. They're going to want you to find the interval of what? One cycle. Okay. And of course, they're going to want you to find the maximum value and the minimum value. They're going to want you to find the x-intercepts, everything we talked about yesterday. And then they want you to sketch the graph, right? So what I want you guys to know here, this is kind of a different example, but be aware, be awake here. Okay? Do you guys remember, what do you guys know about sine? If I said to you sine of minus any angle, what do you guys know about sine? What is that? Is sine even or odd? That's why you did some of the homework. It's odd. So what does that mean? Minus sine theta. Remember, you don't want to wait till the night before. So that means y equals here minus what? Sine of 3x. Because remember this. This k value needs to be what? K needs to be positive. That was in your general format. That k value needs to be positive, if you guys remember that. And then if nothing's in front of sine, by default, what does that mean for a? A is what then? A is 1. Is that true? So what I want to remark, ladies and gentlemen, you might see something like that. They want you to remember sine is an odd function, so you can pull out that negative sign. Okay, cosine is not, but sine is. You get to pull that out. So this is really about graphing. I wanted to get the highlighter. This is really about graphing this function here. Okay, so you guys okay with that one? Now you might say, does that change my a? And I say it sure does. Because now what is a? A is -1. It doesn't change your amplitude though, because the amplitude is the absolute value of a. So you can say, is that the absolute value of -1? It is, and the absolute value of -1 is what? 1. So notice, ladies and gentlemen, I'm using the definitions. Every time I use them, I write them down because why? It helps you to what? To remember them. It helps you to memorize these things. Okay, so that's my advice to you. Every time you use it, you write it down. Yes? Yes. Because 1 times anything is what? Itself. You need an a value. Don't say 0. Sometimes people say, I don't see it there. It's gone. 0. Well, what's 0 times anything? 0. So, it's a is going to be that 1. But because we had the negative sign, we pulled it out because sine is odd. Now a is really going to be -1. So you remember. And that's why we put this what here? -1 there for the a value. All right. So you got the amplitude. All right. Now, after you get the amplitude, what do you have to get? The period. How do you get your period again? It is 2 pi over what? What's the definition? 2 pi over k. Okay. Now I can, every time I use this, I write that down. What's the k value going to be now? Is that 3? Isn't k 3 here? Remember, k is positive. So it's going to be there. K is 3. So there you go. Now, this is my what? Period. Okay, you can't simplify that fraction. All right, what's your interval of 1 cycle? I. Start at 0, you end where? Maybe you said, Mr. Judge, I want to memorize that formula. Okay. Start at 0, you end where? 2 pi over 3. So they're going to ask us for this as well, interval of 1 cycle. All right, where do you start and where do you end? So far, so good. Everybody okay with that one? Because, they can sneak that negative sign on the inside and it comes out on the outside. Because sine is odd. That's why you actually learned about that. All right, so in order to answer the rest of the questions, we're going to have to start to do some arithmetic, right? So you say, what do you mean? Yeah, we're going to have to start to draw this y-axis. And let me see if I can. Yeah, I can do it that way. Okay. All right. Okay, and so the interval of 1 cycle, it starts at 0 and it ends where? It ends at 2 pi over 3. It's your x-axis. This is your y-axis. Is that right? So this is one of the reasons why you care about where it what? starts and where it what? Ends. Okay? So what are you going to do with this information now? What do you guys do? You're going to have to find all those what? Midpoints. Is that right? So I don't know what's midway between 0 and what? 2 pi over 3. Anybody know what's midway? Well, you're going to have to do your arithmetic. So you say 0 plus 2 pi over 3 divided by 2. Now remember, what's 0 plus anything? It's itself. Good. And then you're dividing by 2. Now this is the vertical definition of division. So you have to write it, in my opinion, say this is 2 pi over 3 divided by 2 because you have a fraction here, okay, divided by a what? Whole number. So this comes down to arithmetic. So what that now means is you got 2 pi over 3 times what? 1/2. What happens with the 2's? They cancel. So what are you left with? That's pi over 3. So ladies and gentlemen, that midway between the 0, the starting point over here, all the way on the left, and the ending point, 2 pi over 3, is pi over 3. So this is where the work is, and this is where people will make their mistakes. It's again, it's arithmetic. Okay, so now what's the next step again, if you guys remember? What do you do here? We need the midpoint here. So you say, well, what's that midpoint? Well, what do? 0 plus what? Pi over 3 divided by 2. And this becomes pi over 3 divided by 2, which is pi over 3 times what now? 1/2. You end up getting pi over what? Pi over 6. So, ladies and gentlemen, this value is pi over what? Pi over 6. Okay, you guys okay with that? Now, let me ask you guys this question over here. What's this midpoint now? Midpoint between what two numbers? Pi over 3 and 2 pi over 3. So what would you do to do that, to find that midpoint? You do some arithmetic. So you say pi over 3 plus 2 pi over 3 divided by 2. What does this give you? Do you guys know? What's your numerator? Pi over 3 plus 2 pi over 3. What's that going to be? It is 3 pi over 3 divided by 2. And that's just going to be what? Pi divided by 2. So, ladies and gentlemen, this comes down to what? Arithmetic. Okay? Arithmetic. You're adding fractions and you're dividing a fraction with a whole number. So, okay, we have a lot of information here to start to do this. What was our amplitude? Do you guys remember? What's the amplitude? 1. So you say, what does that mean? Positive 1 here, negative 1. Is that right? You guys okay with that? You're going to use that amplitude. Now, let's be careful here. We got to know what we're graphing. Right? You got the midpoint. We got to know what we're graphing. What kind of curve am I graphing again? So you go back and you say, oh, they want me to graph what? sine. But what's the problem here? That -1 in front of sine, you guys know what that does. It does what? It reflects the curve, the sine curve, about the x-axis. So it's going to end up looking, you're still starting where? 0. But then now you go down here, back to the x-axis, the highest point, back to the x-axis. So I can start to sketch that curve here. And there you go, ladies and gentlemen. You're done. That's the graph, okay? That's the details. Now, you say to me, why is it so important to get all of this other information to do the arithmetic, right? Because ultimately, again, I'm going to erase, well, I don't want to erase. Ultimately, we want this location, and this location in red. What's so special about those locations here? Those are x-intercepts. Okay, so you're going to see and hear that phrase in a lot of math and science courses. Because where a curve equals 0 is like saying, where is a curve neutral? Equals 0. And they want to always know those kind of things. So I want you guys to note and start to get used to that. X-intercepts happen when x equals what? 0. When x equals pi over 3. And when x equals what? 2 pi over 3. Okay? In this interval of one cycle, this is where your curve crosses the x-axis. And then I'm going to ask you, do you guys know what it looks like to stand in a hill or a valley? Right up here, you're on top of a what? A hill. Is that true? Right in here, you're in a what? A valley. So what we say, the maximum altitude of the hill, what's the maximum altitude? Do you guys know what measures your altitude? Right in here, the y values. What's the maximum altitude? Okay, I'm going to erase that and erase that. And I'm going to do this instead. Just put the arrow. What's the maximum altitude? It is 1. Where does that maximum altitude happen? Oops. Let's change that color. Where does it happen? For what value of x? Pi over 2. So that happens, the maximum happens when x equals pi over 2. You care about that. What's the minimum? What's the depth? You say there's a minimum? Yes. That's kind of like, think of this as like below sea level. Okay, this is like below sea level. Your x-axis is sea level. So this is minimum value is going to be what? -1. Where does that happen? When x is what? So let's get the green highlighter. When x is pi over what? 6. I can't draw an arrow. Draw an arrow. Oops. It's the other way. Happens when x is pi over 6. Okay, so this is the reason you care about those what? Amplitude values, ladies and gentlemen, and all those x values. All that information is useful information. This is why you graph the curve. Okay, you guys okay with that? Wasn't that kind of what we went over yesterday? But I added a little wrinkle. So today, here's what I'm going to do today here. I'm going to go back to Microsoft Excel. I'm going to get rid of the sine curve, and we're going to do the same. Come on, sine curve, go away. There we go. We're going to do the same thing for cosine. So you have the x-coordinate, y-coordinate. On the x-axis, those are your arc length values. Those are s on that unit circle again, okay? Because those are real numbers. Yes, they can represent degrees, but they're arc length. Here's the y coordinates. Okay, this is cosine of those arc lengths. So what I'm going to do here again is I'm going to highlight that, and I'll say insert this picture. Really, it's going to be just plot the points. And when you plot the points here for cosine, let's see what this looks like. Okay, you guys see that there? Where do you start with these points? Where's the starting point? This is not sine, this is cosine now. You can see that. You start at 1, is that true? And then you come down to the x-axis, then you go to -1, you go back to the x-axis, and then you end again. The highest point is +1 again. So it has a different starting point and a different ending point, right? So in Desmos as well, okay? Let's get rid of this. I did this in Desmos. Generally speaking, as you guys can see here, maybe you can't see. Cosine is periodic. That means it goes on forever. So you imagine if you had to draw this curve forever? We're not going to do that. What we're going to do instead is do an interval of what? 1 cycle. I'm going to say that again. We're going to do an interval of 1 cycle. So we're restricting the domain again. That's going to be from 0 to x to what? It should be a pi symbol, but I guess they want us to spell it. To 2 pi. So this is cosine for the interval of what? 1 cycle. Okay, so take a look at that. You start at 1, you go down to the x-axis, you go to the lowest point, -1, then you get back to +1. So it has 2 locations for the maximum. Top of the hill, 1 location for the valley. So how does that look? Well, let's draw the picture here, right? Your very simple curve for y is cosine, ladies and gentlemen, because this kind of shows up too. Okay? 1, -1. This is what that picture was showing us. Goes from 0 to 2 pi. Halfway is pi. Halfway to pi is pi over 2. And then you have that what again? 3 pi over 2. Okay? But this time you start at 1. And then you go down to the x-axis. And then you go to the lowest point. You get back to the x-axis. And then you go back to the highest point here. So the cosine curve looks like this. And then that's just for what? For the cosine curve. Okay? So I want you guys to note a few things. Yes, for cosine, the amplitude is 1. The period is 2 pi. And yes, your interval of 1 cycle goes from 0 to 2 pi. Okay, this is what you're looking at. But notice the cosine curve starts at what? 1 and ends at 1. The cosine curve has 2 locations for what? X-intercepts. So if you said, okay, what are the x-intercepts? Well, it happens when x is what? Pi over 2, and when x is 3 pi over 2. Okay? And you say, what about this special point? Oops, let's get the highlighter. Well, this is where you're at a maximum. This is where you're at a maximum. So if you are standing here and here, you're at the maximum value here. Okay? So what's the maximum value of cosine? It's the amplitude. It's 1. Okay? And that happens when x equals what? Remember, this is when x is 0. Right in here, x is 0. And it happens when x is 2 pi. over here, if you're standing right in here, you're at the what? You're below sea level again. So you have a minimum altitude. The minimum is -1, and that happens only when x is pi. So, ladies and gentlemen, this is just the fundamental cosine curve, okay? Cosine alone. That comes from the Microsoft Excel spreadsheet by plotting points here. Okay, so that's your curve there. Now, of course, what are they going to say? They want you to know how to graph these things in general. You say, what does that mean? Well, they're going to give you y equals a cosine kx, where again, k is positive. Okay, and again, what's your amplitude here? It's the exact same thing, the absolute value of a. What's the period again? It's what? 2 pi over k. What is the interval of one cycle? Well, the interval of one cycle, again, is from 0 to what? 2 pi. I'm not going to go over the generalization curve again. There's a picture in your book. But they're going to now say to you to do the same things now, but now they're going to give you y equals 4 cosine, let's say what? Let's change this. Y equals 2 cosine 4x now. So we're going to have to go through the same process, ladies and gentlemen. Okay? But this time, what do you guys know? We know some information here. I'm going to color coordinate this. Here's K, right? Here's A. So could you guys tell me what the amplitude is? Well, it's the absolute value of 2, which equals what? 2, so you're okay with that. Good. What's the period going to be? 2 pi over k. What's k? Is that 4? What is this reduced to? Is that pi over 2? Okay, you guys okay with that? Pi over 2? What's your interval of one cycle, ladies and gentlemen? 0 to what? Pi over 2. Good. Okay, you guys okay with that? Easy peasy, lemon squeezy. So you're going to need to know your definitions. And then, ladies and gentlemen, we're going to have to get the other values here, like the x-intercepts and the highest value and the lowest value. We're going to have to do what's really kind of known as the analysis, ladies and gentlemen. Okay, you're going to use the amplitude. What's the amplitude again? 2. So what does that mean? That goes here. Is that right? That's going to be positive 2. That's going to be what? Negative 2. This is on your y-axis. Okay. How do we use the period? Well, we know we start at 0 over here, and we end where? Pi over 2. All right? You guys okay with that? Okay, so tell me, what do you guys think comes next? What happens next with this? I need the midpoint. What's midway between 0 and pi over 2 now? You add, you divide by 2. Is that right? Pi over 2 divided by 2. So what happens here? Write it vertically, and then now this is pi over 2 times what? 1/2. What do you guys end up with? How do you multiply fractions? Straight across. That gives you pi over what? 4. So we're going to have to do some arithmetic to get these points. So this will be pi over 4. All righty. Now, how do we get the next midpoint? What do you guys think? How do you get that point? Do you guys want to tell me what that's going to be? 0 plus pi over 4 divided by 2. 0 plus anything is what? It's self divided by 2. Pi over 4 times 1/2. What does that give you when you multiply fractions? That's pi over what? It's pi over 8. All right. Good. Okay, what's the next midpoint? Over here. Right? Midway between what? It's pi over 4 plus pi over 2 divided by 2. Okay? So do you guys remember again? How do you actually add these things? You don't have the same denominator, is that right? So what do you guys do? Right? We're over here. How do I get the same denominator? There has to be a 4. What do I do? Multiply the top by 2, the bottom by 2. Is that right? And what do you guys end up with here? What's this? What do you guys end up with? Pi over 4 plus what? 2 pi over 4 divided by 2. Don't you now have the same denominator? So what do you get for the numerator here? What's pi over 4 plus 2 pi over 4? Isn't that 3 pi over what? 4 divided by 2? Is that true? Because remember how you guys add fractions? Same denominator. Okay, we keep that. Now you get to add your what? Pi plus 2 pi gives you what? 3 pi. All right, you're almost there. Almost there. 3 pi over 4 now divided by 2. What is that? Do you guys remember? Isn't that 3 pi over 4 times 1/2? And what does that give you? That's 3 pi over what? 8. Good. Good. All right. So then this becomes 3 pi over what? 8. All right, you guys okay with that one? Easy peasy lemon squeezy. So let's ask you guys this question now. What do you do now with all of these points and these locations here? You got to know what you're graphing. What are you graphing? Go back and take a look. This is going to be what? The cosine curve. So what you're going to have to know is, how does that cosine curve behave? Do you guys know what I'm saying? You start at the highest point. Is that right? And then you're going to end at that highest point. So, all right, so that's cosine. So here's the deal, right? So we say, well, here's where we, what again? We start right up here. Then you come down to the x-axis. Is that right? And then you get to the lowest point. You go back to the x-axis. And then you go to the highest point. And I'm going to move that here. Okay? Because this is how the what curve behaves. The cosine curves. So you're going to have to know the difference between sine and cosine. So now when you sketch, how does that sketch look? You come down. Remember, both my parents are artists. And I have to kind of get to the side here. And there you are, ladies and gentlemen. There's the graph. That's how you handle what? Cosine. Okay, so what I'm going to now do here, I'm going to erase some of this nice work so we can actually look at the curve and study it, because again, that's the whole point. The whole point of sketching this phenomena is so that we can see what's going on. Okay. So let's ask you guys here, now that you have some experience here, where are your x-intercepts? Right? An x-intercept is where the curve hits the x-axis. It happens when x is pi over 8 and x is what? Pi over 8. It's those red points. All right. What else is important for us to know? Do you guys remember? Use green. Oops. What else is important to know? The highest points and the lowest points. Is that right? So what's the maximum value of cosine here? Good. It equals 2. Now, for what values of x does that happen? Nope. If you're on top of this hill, right here, what's the location for x? It is 0. What else? Pi over 2. Okay, that even helps you, ladies and gentlemen, I would say, to remember how cosine behaves. Maximum value. What's the minimum value for cosine? Where are you in that valley, right? You're below sea level. The minimum value, what's the minimum value? The depth. It's -2. Okay. And for what value of x does that happen? For only one value. It happens when x is what? Pi over what? 4 there. Because I know you can't see it, but okay, you can't see that. So you want to start to get used to that idea. This is on top of a hill in a valley. This is the nature of the cosine curve, and this is how this curve behaves right here. 2 cosine 4x. I'm sorry about that. Easy peasy lemon squeezy, ladies and gentlemen. All right. Let's give you guys another example here for cosine. What did they give you? 1/2 cosine minus 1/3 x. So what do you guys want to remember here? You have an issue, right? What's the deal here? That negative sign. So what do you guys know about cosine? It's an even function. What does that mean? It means that negative sign makes no difference, right? Because remember, cosine of minus theta is cosine of theta because it is even. Ladies and gentlemen, there you go. So don't fall for that trick when they put it there. So now you can say my amplitude is the absolute value. Remember, this is the A value. What is this? K. Okay, you're going to look for those two numbers here. So if A is 1/2, we say, what's the absolute value of 1/2? That's going to equal what? 1/2. Okay. Now, what's your period? Isn't that 2 pi over K? So that's 2 pi divided by 1/3. And again, you're taking a whole number now and you're dividing by the fraction 1/3. Is that right? So that's 2 pi now times the reciprocal of 1/3 is what? It's 3 over 1. What does that really mean? Your period is what? 6 pi. Okay? So we want to know the amplitude. We want to know the period. And again, what's that interval of one cycle we just talked about? Where do you start here for this again? Okay, and where do you end? There you go. So this is all the information they want for us to begin to start to sketch the cosine curve. Okay, so now, ladies and gentlemen, you say, well, what happens with this stuff now? Well, start to sketch. So we're going to start to sketch this. Okay, so I'm going to put this here and up here. What is the amplitude again? 1/2. Okay. You're using that amplitude value you found? Okay. And now the period is what? 6 pi. So that goes from 0 to 6 pi. So that's why we have that interval of one cycle. This is why we got this information. We're going to now do the halfway. Now, sometimes you get so good with this computation, you could do it in your head. What's 0 plus 6 pi? What's 6 pi divided by 2? 3 pi. What's 0 plus 3 pi? 3 pi. What's 3 pi divided by 2? That's 3 pi over 2. What's 3 pi plus 6 pi? 9 pi. What's 9 pi divided by 2? It's 9 pi divided by 2. Did you guys see what I'm saying? Some of these questions are pretty good to find that midway. Okay? What do you think? Easy peasy lemon squeezy? It's arithmetic, ladies and gentlemen. Arithmetic. You got to focus on that arithmetic. Now, okay. So now, what am I going to say here with this? What comes next? What curve are we graphing again? We're graphing what? We're graphing cosine. So if you're going to graph the cosine curve, you got to know, how does cosine behave? Oh, it starts at the highest point. And then it goes to the x-axis and goes to the lowest point, back to the x-axis, back to the highest point. So you go, okay, it starts highest point, goes to the x-axis, goes to that lowest point back to the x-axis and back to the highest point, because this is cosine. Sketch or what? Oops, I'm gonna have to go all the way over here. Sketch your cosine curve. All right, you guys okay with that one? And so now this is all about, can you even read this picture? Because why are you going to draw a picture if you can't even read it? You guys know what I'm saying? Why draw the picture? We want to read it. Okay. In red, what are those called? Good. Where does that happen? When x is 3 pi over 2, what's the other value? Remember, that's the sea level, ladies and gentlemen. That's where cosine is 0. Those are important locations where cosine is 0. And I guess I'm going to get out green again. This location and this location. What does that mean? What am I saying now? What's the maximum value of cosine? 1/2. And where does that happen? X is 0. What else? There you go. Okay, over here again. What is this? Isn't that the minimum value? Okay, what's the minimum value going to be? -1/2. Okay, when does that happen? X is 3 pi. So remember, a picture is worth 1,000 words. That's why you draw the picture. And, we're going to see how this is even used. Okay, it's important. All right, you guys okay with that one? Easy peasy lemon squeezy. All right. I'm going to try this. Just going to do -3 cosine 2 pi x. Okay, so now remember this. Just like yesterday, I'm going to highlight the important pieces of information. This is A, and this is K. Is that right? We're going to need all those things again. We're going to need the amplitude now. It's always the absolute value of A. What's the absolute value of -3? 3, good. Period. 2 pi over K. What's K? What's 2 pi over 2 pi? 1. Good. I don't know. Do the colors help, ladies and gentlemen? I don't know. Do they? What's your interval of one cycle? You start where again? 0. Where do you end? 1. You end at that period. Oops. One color. All right, you guys okay with that? Easy peasy? What do you think? Okay, what do we do with this information now? Do you guys remember? We're gonna draw our picture. We're gonna draw our graph. A picture's worth 1,000 words. Let's try this out. Okay. So what's that amplitude again? +3 and what? -3. Okay, interval of one cycle, 0 to what? 1. Isn't that going to be your what? period there from 0 to 1. You say, but I don't see the 0. Well, they usually don't put the 0. I'll put it. Okay, you guys okay with that? Now, what do you guys do? You guys know the halfway? What's halfway from 0 to 1? 1/2. So what do you put? 1/2. Do you guys know what's halfway from 0 to 1/2? What's that going to be? What is it? 1/4. Good. What's halfway over here? You say, I can do these in my head, but Mr. Judge, the second you give me this one. All right. So let's do some arithmetic. What do you guys think? Is arithmetic important? Like I told you guys the other day, I'll tell you, if people have trouble with algebra, that's not the problem. The problem is not algebra. The problem is what? Arithmetic. You say, why? Because algebra is based on arithmetic. So here's where the issues will be, right? So 1/2 plus 1, do you guys remember? You might say, oh, it's 1 over 1. Yeah, and the fractions are not like. What was that trick I've been showing you guys here? That little shortcut, right? What are you going to do? Multiply the top and bottom by 2. Why? So you can have a common what? Denominator. Because that's the only way you can add. Because over here, this is what? 2 times 1, and then, well, 1 times 2, 1 times 2. And then you go, oh, I know. What's 1/2 plus 1/2? 1. Good. What's 1 divided by 2? Well, that's the definition of 1/2. This is what we did. So we did something wrong. 2. I'm sorry. We did something wrong. That's supposed to be a what? 2. Okay, now what do we do? Yeah, you have to add the 1 plus the 2, giving you a what? 3. You keep that 2, but don't forget there's another 2, right? So you got 2, 2. This is a 2. You're adding again. Now it's like fractions. So what is this going to give you? What do you guys think? Yeah, like I said, I was that student. I had to do this, lady. I still do it. I don't skip that step. What's this going to be? 3/4. I still do it, ladies and gentlemen, because I know if I don't do it, what's going to happen? I'm going to make a mistake in my arithmetic. So, ladies and gentlemen, there's no shame in you doing your arithmetic. None whatsoever, because this is what it's all based on. It comes down to. All right. It's all in that video. Anybody go back and watch the videos and just say, okay, I'm going to have to go back maybe? Right? You guys know what I'm saying? Coach, did Coach put up any of that? No. I don't even want to ask. Coach. All right, what do you guys do? You guys remember? What do you guys do? You go back where? And you look at this and you say, I'm going to have to graph what? The cosine curve, but what's the deal? It's a negative number in front. Okay, what does that do? What does that negative number do, ladies and gentlemen? Do you guys remember what that does? What does it do? Just like yesterday, what does it do? Do you guys remember? Yeah, it reflects your curve about the what? About the x what? Axis. Is that true? All right, you guys know what I'm saying? It's going to reflect your curve about the x-axis. All right, now. So you might even say to me, hey, I kind of know what cosine looks like, right? This is what we've been doing with cosine. Is that right? Isn't that the cosine curve? But I drew the ghost curve. You say, what's the ghost curve? Because if you reflect and you put that mirror about the what? Put your mirror about this x-axis, and you reflect every point. You say, I got to reflect this point? Yes, it's now down here. Oh, what about the x-intercept? Well, it's on. You can't reflect it. It's on the mirror. Well, what about the point down here? It's reflected. It's now above, ladies and gentlemen. And then again, the point on the x-axis can't be reflected. The tallest point can be reflected. That's going to be where? Down here. So your curve looks really like this. So be careful. Don't what? Don't forget to use the mirror. Okay, now to get rid of the ghost curve, okay? And that's what you have to graph. That's your information, okay? However, a picture is worth what? A picture's worth what? 1,000 words. Why do I say that? This point and this point, they're on the what? X-axis. So what are they called? X-intercepts. Good. What does it happen? X is 1/4 and X is what? 3/4. Good. Okay, let's get out orange. If you're standing here and you're standing over here, you're standing in a what? What are you standing in? A valley. Good. And you're at below sea level. So what does that mean? The minimum altitude is what? -3. When does that happen? X is 0 and X is what? 1. That's when it happens, okay? But you're in that valley. That's your altitude. The y-axis, think of that as your altitude. Don't you have a max? Yes, you're standing up here. What's the maximum altitude? 3. When does that happen? And there's only one hill. So it's like on top of a hill in a valley there, right? So ladies and gentlemen, this is the picture you care about. This is the picture they want you to draw. Okay? What do you guys think? Easy peasy lemon squeezy? Should we have you guys try one? Okay, I'm going to look at my little worksheet here. Let's have you guys try one. Where are you, worksheet? Let's say y equals 3/2 cosine cosine x over 4 here. Okay. I'm going to give you guys some time to work on this one. Where's our clock? And of course, we'll go over it. All right, ladies and gentlemen, take a look at this right here. This is kx. Is that right? So what happens is people mistakenly think that k is 4, and it's not. Because x over 4 is rewritten right in here as 1/4 x. Right in here. So that means k is going to be now what? K is 1/4. So then a whole number like 2 pi divided by the 1/4 becomes 2 pi times 4. In other words, your period is 8 pi. So you start at 0 and you end where? 8 pi. Okay. All right. Ladies and gentlemen. Okay, let's get all the information. What do you guys think? Did that get anybody by any chance? Huh? That's why you do these questions. When do you want to get started on this? Yesterday. You guys know what I mean? Okay. Now, how do you do the rest? Do you guys remember? The amplitude. What's your amplitude? 3/2. Okay. So you put your 3/2 here, minus 3/2 here. 0 to what? 8 pi. So what's half of 8 pi? 4 pi. Good. What's half of that? 0 to 4 pi. Isn't that going to be what? 2 pi. And then from 4 pi to 8 pi, what's half of that? 12 pi divided by 2. That's a 6 pi. Do you guys see what I'm saying? So some of this stuff you can do sort of in your head. All right, now, what do you guys do next? What do you guys know? What kind of curve is this again? This is the what? Cosine curve. It's a cosine? Yes. How does cosine behave, ladies and gentlemen? How does that cosine behave? Do you guys know how cosine behaves? Starts at the highest point, goes to the x-axis, goes to the lowest point, back to the x-axis, back to the highest point. So you're going to start, ladies and gentlemen, here, x-intercept, lowest point, x-intercept, the highest point, and then you're going to draw your what? Oops, sorry. Told you. You'd never guess my parents are what? Artist. Let's see what this information means again. Okay? Where are the x-intercepts, ladies and gentlemen? 2 pi and what? 6 pi. You're at sea level here. Okay? Now, where are you at the maximum altitude? You're at a max. What is the max, by the way? Right? You're on top of a hill. What's the altitude? 3/2. When does that happen? When x is what? And when x is what? Okay. You're at a minimum altitude. Where is that? Okay. And then x equals what? 4 pi. So, ladies and gentlemen, just to let you guys know, here's your x-axis, here's your y-axis. What I'm going to do really for some of your homework, you see this sheet that I have here for you guys? I'm actually going to make that, let me go back if I can, scroll out. I don't know. Yeah, there we go. I'm going to make that kind of your homework. Okay, but I'm going to have to go over some of these myself. I'm going to have to make a video. What do you guys think? Is that a nice video time to go over some of those solutions for you? So I'm going to make that, because what happens is, I think to some degree, if you start doing the book work, You're going to say, what about this question? What about that question? This has a phase shift. What about oh my God, what happened with the phase shift? What happened with this? People get a little frustrated. So I'm going to make this sheet, but I have to now do the solutions too. I don't know. It's called Graphing Trig Functions 1, maybe. So let me go back here to find our canvas. Graphing Trig Functions 1. And I'm going to have to make a video. I'm going to, that's what I do. Is that right? So, just so you guys know, let me do this here. I'm going to put that there. I'm going to call this what? Part 1. And I'm going to put the link here. And then be on the lookout this weekend for some what? Video solutions, because I will contact you when I do that. I'll set it up there for you guys, okay? So I think those are good to really get started with so that you don't get discouraged. And this is going to be all the stuff we actually what? Worked on. Does that make any sense? All right. Okay, you guys. Take care. Stay safe. We'll see you guys when? On Monday.